In this video, I'm going to go through the IXL skill transformations of quadratic functions. So we're tasked to find g of x, where g of x is the translation 10 units up of f of x equals x squared. We're going to write our answer in the form a times x minus h squared plus k, where a, h, and k are integers. So this just basically means it's going to be this quadratic function in vertex form. Now, we have this parent function, right? This is our parent f of x equals x squared. And the goal is to translate this 10 units up. And please make sure you have good notes on transformations, all the different transformation rules that we have. So in module 6b, let me view as a student. In module 6b, we have the resources on transformations, if it will load. There we go. I put my notes in the 6.5 notes and the 6.6 notes, and then also in the extra help folder, there are some additional resources, including tables going over all of the different translations. This one is the translation section in the translate quadratic functions. If you go back to the module, there's a lesson on reflecting and dilating as well. So in the extra help folder for reflecting and dilating functions, I also have that transformations table in here as well. So these rules are very helpful as you work through these problems. If I want to take a quadratic and move it 10 units up, a translation, I'm just adding or subtracting that value either outside of the entire function, causing it to move up or down vertically, or if I want to go left or right, then I'm going to have that value added or subtracted in with x. Since we want to go up, this is just vertically moving the graph up 10 units. So g of x is the same thing as x squared plus 10. And you can always graph this in Desmos too to see what that looks like. Let's see, maybe x squared plus 10. And before I type this in, let's go to Desmos and let's just type, here's f of x equals x squared. And then let's try x squared plus 10. I'll have to zoom out a little bit, but you'll notice that the graph of the green parabola has been shifted up from 0, 0 to 0, 10. The vertex is shifted up 10 units. So that's how we know that it's been a translation. 10 units up. All right, next one that I wanted to look at. Find g of x, where g of x is the translation 9 units left of f of x equals x squared. So when you're going up or down, that's when you have the plus k or the minus k outside of the x squared. If you're going left or right, that is going to be added or subtracted in with x. So I have f of x equals x squared. To move it 9 units to the left, I'm going to add 9 to x, and that will be squared. So g of x equals x plus 9 squared. And we can see this in Desmos as well, right? We have f of x equals x squared. Let's just delete this one and write x plus 9 squared. And you'll notice from the original green to the new transformed black function, we have shifted 9 units to the left. So it's kind of opposite of what you would think, because oftentimes when we think plus 9, we would think to the right towards the positives. Because it's in the parentheses being squared, it's actually opposite. Notice if we had x minus 9, that would cause it to move to the right. So correct answer here is x plus 9 squared. Oop. Close that. There we go. Squared. All right. We're going to find g of x, where g of x is the reflection across the x-axis of f of x equals x squared. And in the notes for reflecting and dilating functions, I talk about how we can add or really multiply by a negative, either outside of the function or inside with x, to cause it to reflect. If I want to reflect across the x-axis, here's the x-axis. That means anything that was originally above the x-axis now is going to be below, and everything that was below is now going to be above. So we're flipping vertically. When you're working vertically, you're working outside of the function with f of x. So really, to reflect f of x across the x-axis, we're going to take f of x and we're going to make it negative. So negative f of x is the same thing as negative x squared. We take that entire x squared and make it negative, which is the same thing as negative x squared. And you can see this if we graph it in Desmos. We have f of x equals x squared. If we rewrite this as negative x in parentheses, or not in parentheses, excuse me, negative x squared outside of parentheses, it's really like negative being multiplied to x squared. It is the reflected function on the other side of the x-axis. All right, let's go to, back here. So g of x is equal to negative x squared. Or you could write it as negative x squared in parentheses. The squared needs to be in parentheses as well. I like it like that though. All right, next one I want to look at was this example. The graph shows g of x, which is a translation of f of x equals x squared. We want to write a function rule that will create this g of x. So again, this is a translation of f of x equals x squared. So here's x squared. It has 0, 0. We have the point 1, 1. We have 2, 4. So I'm going to kind of draw a rough sketch on this graph of the parent function. We know the parent function is f of x equals x squared. That has the vertex at 0, 0. We have 1, 1, 2, 4 as a point. We also have negative 1, 1. We have negative 2, 4. So here's the parent. It looks like this graph has just slid to the right. If I compare the vertex of the parent, it's at 0, 0. It slides from 0 to 4. This is 1, 2, 3, 4 units. We have moved to the right. So translation, 4 units right. To translate a function, this parent function, 4 units right, remember going left or right is when you're going to have that number added or subtracted inside of x. So this parent function, f of x equals x squared, g of x is found by subtracting 4 from x. X minus 4 squared tells us to take that x squared and move it to the right 4 units. That's what the minus 4 in parentheses tells us. And you could always test this on Desmos as well. Right, if I try, we already have the x squared there. If I try x minus 4 squared, oops, it has moved to the right. And again, how do we know which translations, which rules to use? Please use the notes that are in the modules. All of the modules have basic directions telling you if you know that you need to move to the right, you are going to have this minus k inside your answer. And I was trying to pull up the video. Yeah. Ooh, I don't want to hear myself though. So notice here I talk about if we're moving up k units, I have x squared plus k. If we're going down k units, it's x squared minus k. Right h units is going to be x minus h squared, and left h units is x plus h squared. So please use your notes. If you know that this function is moving to the right 4 units, you'll have x minus 4 squared. All right, so final answer here, x minus 4 squared, because it's moved 4 units to the right. All right, I wanted one more, like this one. We're going to find g of x, where g of x is the translation 9 units left and 5 units down. So we want to go 9 units left, and we want to go 5 units down. And our parent function is just that f of x equals x squared. So to move 9 units left, we're moving horizontally. That's directly affecting x values. So we're going to have a number either added or subtracted with x. And since we're going to the left 9 units, I will have x plus 9, in parentheses being squared. And then to go 5 units down, I will simply subtract 5 from the outside of this. So if f of x is equal to x squared, then g of x, our translated function, 9 units left and 5 units down, would be x plus 9 squared, squared outside of the parentheses, minus 5. Please, please, please keep practicing. Practice makes perfect. In this example, we've moved to the right 9 units and down 1. So this is going to have two translations here. We have to go to the right 9 and down 1. So you should have a -9 inside the parentheses and a -1 outside. These take some practice. Please let me know what questions you have, and don't forget to use Desmos.